So I'm going to talk about Euler's method, and Euler's method is basically a way to find solutions of first-order differential equations numerically. And so it's sort of hard to explain in words, so I'm just going to jump straight to an example. So here's the example. We have dy over dx, the slope, this right here is a differential equation. Dy over dx equals 3 over x. And your delta x is 0.5. The p sub 0, the first point we're looking at, is 1 comma 0. And basically, using Euler's method, we have to find p1 and p2. So I'm going to begin first by finding the slope at point p sub 0. And so we have the slope right here, dy over dx. So dy over dx equals 3 over x. And x in this case, from our p sub 0, is 1. So at p sub 0, our slope is 3. And so basically, now our y sub 1 equals our y sub 0 plus delta y. Now we know y sub 0, that's just right here, 0. But we have to find delta y. And so basically, dy over dx equals delta y over delta x. Using some algebra, we can isolate delta y and make it equal to dy over dx times delta x. And so we're just going to use this guy right here to find our delta y, and in turn find y sub 1. So delta y is dy over dx, which was 3. We just found that. And then our delta x was given to us in the problem, 0.5. So our delta y is 1.5. And so let's solve for y sub 1. Y sub 1 equals y sub 0, 0, plus our delta y, 1.5. And that equals, or y sub 1 equals 1.5. And our x sub 1, same thing, equals x sub 0 plus delta x, and that equals 1 plus 0.5, as it was given to us in the problem, and that equals 1.5. So we have p sub 1 equals 1.5 comma 1.5. So that's basically how Euler's method can be explained in an example. And let's quickly find p sub 2. So same thing. Now our dy over dx at let me see one sec. At dy over dx times delta x, times delta x sub 1 is our delta y for p sub 2. So dy over dx is 3 over x sub 1 now, and we found that was 1.5. And then delta x is still 0.5, so we find that delta y equals 1. And so now we go over here. We have y sub 2 equals 1. That was our delta y, plus our y sub 1. And our y sub 1 we found was 1.5. So now our y sub 2 is 2.5. And our x sub 2, do that really quick, was 1.5, our x sub 1 plus delta x given to us in the problem, and that equals 2. So over here, p sub 2 equals 2 comma 2.5. And this is the basic gist of solving first order differential equations with Euler's method.